First, you will need to power up your tester. Connect the power input plug into its socket, then power up your tester. After that, we will connect our crocodile clamps. Black for minus, red for plus. Then we can start the tester. When the tester is ready, we will connect our DUT. On the main screen, we can see many options, so let's get through them. The first, we have ideal L, which is the ideal oscillation curve at a given inductance value. Next, we have state option that can be used to active or deactivate the display of the ideal L waveform of the ideal inductance. In addition, the value O frac, which means frequency of the oscillation curve, and O cycle, which means time period for one oscillation period, are displayed as well. The next step is sample, where we will set up our master curve. As a first setting, we have voltage, where we will set up our test voltage between 200 volts and 6000 volt DC. The next one is DIV, where we will set up the sampling speed of the IDV converter. In a step AVG, we will set up the number of the voltage surges. For the lens option, after recording the master curve, the determined inductance of the DUT is displayed. This value is purely informative and cannot be changed. After everything is set up, don't forget to save the master curve. The next one is the test option, where we will compare our master curve with the next DUTs. I will show you this later. The next one is TPM, which means three-phase motor testing option, where we can measure all three phases separately. In the section Compare, we can choose from many options how to compare our master curve with the new DUT. The first one is Area, where we can set up our error area. The next one is Diffa, where we can set up our differential error area. Next, we have Coron, which is corona discharge number, and after that we have Coros, which is corona discharge energy. Now I will describe you the values we can set up for all of these four methods. Cursor L sets the left limit of the time interval that is evaluated. Cursor R sets the right limit of the time interval that is evaluated. THR, which means threshold, will set the limit values for the respective evaluation procedure. The last two steps are LPE, which is inductivity comparison, and CDCP, where we can measure partial discharge strength. The last option is the setting, where we can find memory, where we saved all our master curves, connect for the remote control of the tester, USB settings for safe results, and much more. Now we will test our DUT. First step will be sample, where we make our master curve. I will set up the voltage for 1000 volts, and I will set up the number of the voltage surges for 10. Then I press start. When my master curve is ready, I press save. Then we will go to the test. In the test option, if I now press start, my master curve will be compared with the DUT. Because it's the same piece, the result is okay. But when I switch the DUT with the different one, with the problem in the winding, you will see the difference between master curve and measured curve. And this is how our surge tester ST6600B works. Here you can see the datasheet, which you can also find on the website for more information. If you want to see more of our products, make sure to visit our website at spselectronic.com. Thank you for your attention and see you in the next video.